Assalamu alaikum wa rahmatullahi wa barakatuh. Let us continue to exercise 1.1 from the sixth question, second Roman. The sixth question being, express the following rational numbers as decimal numbers. So we were there here in the second Roman. First bit is 2 by 3. We know that every fraction can be converted into its decimal form, and the decimal can be converted into fraction. So to convert 2 by 3 into its decimal form, we need to divide 2 by 3, considering 2 as dividend and 3 as divisor. So let's convert 2 by 3 into its decimal form. We need to divide 2 by 3. 3 zeros are 0. Decimal division is finished, so let's keep the decimal point. 3 6 are 18. Remainder is 2. Let's keep 0. 3 6 are 18. So it keeps repeating. Let's continue it here. Again 3 6 are 18, and it continues this way. So 2 by 3 is equal to 0.6666 and so on, which means 0.6 bar. So it is its decimal form. See the sixth question, second bit, minus 25 by 36. So let's divide 25 by 36 to know its decimal form. 36 zeros are 0 because 25 is less than 36. Remainder is 25. Keep the decimal point, put a 0 here. 36 6 are 216. 0 becomes 10 and 5 becomes 4. 10 minus 6 is 4. 4 minus 1 is 3. Now 36 9s are 324. The remainder is, so 0 becomes 10 and 4 becomes 3. 10 minus 4 is 6. Let me write it here. 3 minus 2, 1. So it becomes 160. So 36 4s are 144. Remainder is again 16. Keep a 0 again. Again 36 4s, 144. Remainder being 16. So in this way it continues. So minus 25 by 36 is equal to 0.69444 and so on. As 4 is being repeated, the bar will be kept only on 4, not on 6 9. So this is the decimal form of minus 25 by 36, and as it is negative, the decimal form minus 25 by 36 is equal to minus 0.694 bar. So as we divide 22 by 7, we know that pi is equal to 22 by 7. So it is the value of pi. So the value is 3.142857 as we divide 22 by 7. You can see the division here. Its decimal expansion is non-terminating, not repeating. The decimal expansion continues endlessly here, but there is no repetition at all. So pi is also said to be as irrational number, which you will read in the next topic. See the seventh question. Express each of the following decimals in p by q form, where q not equal to 0 and p, q are integers. So here we have to convert the decimals into fractions. First bit is 0.36. So its fractional form is 36 by 100. As there are 2 digits after the decimal point, we will keep 2 zeros in the denominator. Let's see the second bit, 15.4. So 15.4 can be written as a mixed numeral 15 whole 4 by 10. So here you can convert this mixed numeral into improper fraction. 10 15s are 150 plus 4 by 10. which is equal to 154 by 10. Or directly you can convert it into 154 by 10, 10 because there is one number after the decimal point. Next bit is 10.25. So this can be converted into 1025 by 100. So 2 zeros because there are 2 digits after the decimal point. Now see the 8th question. Express each of the following decimal number in the P by Q form. First bit is 0.5 bar. Children, you already know how to convert 0.5 into its fractional form, which is equal to 5 by 10. This being easy, 0.5 bar has another method using which we can convert this non-terminating repeating decimal into its P by Q form. So let us see what is that method. You're already acquainted with this method in your 8th standard. Let x is equal to 0.5 bar. So we will proceed this way. I think you remember. X is equal to 0.55555 and so on because it is non-terminating. So multiplying 10 on both sides of this equation. So we are multiplying 10 on both sides of the equation with LHS, that is 10 into x, and also RHS, 10 into 0.5555 and so on, which gives us this 10x is equal to, the decimal point moves this side because you're multiplying with 10, 5.5555 and so on. Now consider this as equation 1 and this is equation 2. You can see the equation 1 and equation 2 here. Now let's the next step. Equation 2 minus equation 1 implies, so equation 2 is 10x is equal to 5.5555 and so on. Equation 1 is equal to x is equal to 0.5555 and so on. Now we are subtracting these two equations. We get 10x minus x is equal to 9x here, and here as we go on subtracting from the right hand side, 5 minus 5 0, 5 minus 5 0 0 0, and here the point 5 minus 0 is 5, which is nothing but 5.000, that is 5. Here 9x is equal to 5, so x is equal to 5 by 9. So x is equal to 5 by 9. 5 by 9 is the P by Q form of x is equal to 0.5 bar. So first of all we assumed x is equal to 0.5 bar and we got x is equal to 5 by 9. So x is equal to 0.5 bar is equal to 5 by 9. The first bit 0.5 bar was discussed now. Second bit is given as assignment. Third bit 0.36 bar. We have to find its P by Q form now. Let x is equal to 0.36 bar, which means x is equal to 0.363636, means 36 which is under the bar is being repeated. Multiplying 100 on both sides. In the last question we multiplied with 10 on both sides of the equation. Here we are multiplying with 100. Why 100? Because see the question. The earlier question was 0.5 bar. So there was one digit under the bar. Now there are two digits, 3 and 6. Therefore, we must multiply with 100. Here, this is LHS and this is RHS. Left hand side and right hand side of the equation. Let us multiply now. Now it becomes 100x is equal to 100 into 0.363636. So here this point moves two digits to the right. So this becomes 36.363636 and so on. So here this is equation 1 and this one is equation 2. Equation 2 minus equation 1 implies 100x is equal to 36.363636. X is equal to 0.3636 and 36. We have to subtract these two equations. Here 6 minus 6 is 0. 3 minus 3 is 0. In the same way, we will get all zeros in the decimal part. 36 minus 0 gives you 36. Is equal to 100x minus x, which is 1x, is equal to 99x. So here 36.0000 means 36 itself. So solving this equation, we get x is equal to 36 by 99. This is the p by q form of 0.36 bar. So x is equal to 0.36 bar is equal to 36 by 99. One thing to note is 0.5 bar, we got the answer as 5 by 9. Here it is 36 by 99. So in denominators usually you will find the digit 9. It will be one single digit if there is one digit under the bar. It will be 2 nines if there are two digits under the bar. The next bit is 3.127 bar, and you can notice that the bar is kept only on 7. So here x is equal to 3.127 bar, which means x is equal to 3.1277777. 7 is being repeated and so on. Now multiplying 10 on both sides. Why 10? Why not 1000? Because there are three digits now, 1, 2, 7 after the decimal point. Why not 1000? Why only 10? Because there is only one digit under the bar, that is 7. So we will consider 10. We will multiply 10 on both sides of the equation, LHS and RHS. Because 10 contains 1 0 and there is one digit under the bar. So as we multiply 10 on both sides, it becomes 10 into x is equal to 10 into 3.127777 and so on. Now 10x is equal to 10 into this point moves to one side, one digit right to its location, because we are multiplying with 10 having 1 0. So 31, it becomes 31.27777 and so on. Now this becomes equation 1 and this becomes equation 2. Equation 1 and 2. Now we have to do what? Equation 2 minus equation 1. So equation 2 minus equation 1, as we start doing the subtraction, here it is 0, 0, 0, 7 minus 2, 5, 2 minus 1, 1, and this becomes 11 minus 3, 8, and 2, 28.15. 10x minus x is equal to 9x. X is equal to 28.15 by 9. X is equal to 28.15 by 9. So this can be written as 2815 or 2815 by 9 into 100, because here decimal point is removed. The decimal point is removed and 100. 9 is multiplied. The denominator is multiplied with 100 because there are 2 digits after the decimal point. This becomes 2815 by 900. After simplification, 5 ones are 5, 4 0 5 8s are 40, 5 zeros are 0. The numerator 5 5s are 25. 3 1 is left out, 5 6 are 30, 1 5 5 3s are 15, which is equal to 563 by 180. So this is the P by Q form of 3.127 bar. So the P by Q form of 3.127 bar is 563 by 180. Now see the 9th question. Without actually dividing, find which of the following are terminating decimals. First question, 3 by 25. Here we are not supposed to divide and just tell whether this fraction has terminating or non-terminating decimal expansion. First bit is 3 by 25. Here without dividing, how can we tell whether this fraction has terminating decimal expansion or non-terminating decimal expansion? See, we have to consider the denominator, which is 25 here, and look at its prime factorization. So 25 is equal to 5 into 5. See children, if in the prime factorization of denominator you find only 2 or only 5s, 2s or 5s, or both 2 and 5, the combination of 2 and 5, then we can consider the given fraction that it will have terminating decimal expansion. What? The prime factorization should contain either 2s or 5s, just 2s or just 5s, or a combination of 2 and 5. So what I said, the prime factorization should either contain 2 or 5 or a combination of 2 and 5. So here we can find only 5. So 5 is appearing in the prime factors of 25. So this 3 by 25, this fraction will have what? Terminating decimal expansion. Similarly, see the second bit, 11 by 18. Now what we will do? Look at the denominator, which is 18. 3 6 are 18. Let's prime factorize it. And 2 3s are 6. 3 1s are 3. So prime factorization contains 3 into 2. Again, let's look at the rule. The prime factorization must contain either 2s or 5s or a combination of 2 and 5. But we can see 3 here. 2 is okay, but we are able to find 3. The prime factorization contains 3. So 11 by 18 has non-terminating decimal expansion. See the last 2 bits, 13 by 20 and 41 by 42. Let's solve them. Consider the denominators 20 and 42. So if we look at their prime factorizations, so 20 is equal to 5 into 2 into 2, whereas 42 is equal to 7 into 3 into 2. So actually these are 2 different bits. So here you can see that We got a combination of 2 and 5 here, so it is terminating in its decimal expansion, as I already told you. Here we got 7 and 3, which are other than 2 and 5, so it has non-terminating repeating decimal expansion. Jazakallahu khaira.